All right, so we are downloading and extracting weatherdata.zip, and then we'll build an Excel file to work with that from scratch. So today we're working with reading and writing text files with VBA. Actually, today we'll just be reading them, but writing them is kind of a simple step from there. So let's see. I think I've already got those files downloaded. Let's take a look at these files. Let's see. I'm in downloads. Weatherdata.zip, but I think I've already extracted it. Weather data, okay. We've got 3 files here in weather data. Let's choose, why don't I choose the second one, 2008 X11. That's the one I want. Just going to open it with Notepad. Yeah, that looks pretty good. All right, somebody tell me, as you open this file, someone tell me something interesting. Maybe interesting is too high of a threshold. Someone tell me something about this file. Tell me something non-trivial about this file. Go ahead. Okay, so we have some structure to it, but it's not like a tab delimited or a fixed width file because we've got this kind of header data built here into the middle of it. And so there's some structure to it, but it's not, kind of a standard export import kind of file. Good. What else? Maybe kind of look and see if you can figure out what data we're talking about here. Or anything else that might be interesting about the structure of the file. Let's suppose you've been assigned to work with the data in this file, and that's what we're going to do today. What can you tell me about it? You stumbled across this file, and now you're trying to figure it out. Hopefully you didn't stumble across a flash drive and plug it in to see what it was, because you now have a virus if that's the case. Okay, so there's something about this structure here. We're assuming the data that we're going to want is in this block right here, and we've either got a dollar or an asterisk. That might be helpful. Anyone have any idea what kind of data we're looking at here? It's not English. Well, parts of it is in English. Parts of it is precipitation in millimeters, so it's precipitation data. Where is it from? Yeah, Brazil. I guess, someone knows this. I don't know what this is, or even how to say it, Minas Gerais. That's a state in Brazil, and are these like cities in that state? Maybe. I think they're actually weather stations that are in this state. And so what we have here is that on November 4th, at this weather station, there was no precipitation recorded. On November 8th, at this weather station, there was 9 millimeters of precipitation recorded. And actually, is that? Yeah, precipitation in millimeters. So that's the data that we're after. Now, seems like a strange way to get the data. Why do we have data that looks like this? Why isn't this just like a comma-separated file, a CSV file? That'd make our life so much easier. Where does this format come from? Any thoughts? It goes back to before most of you were born. I mean, not this file, but the reason. Go ahead. Okay, so it's some kind of output, but particularly the interesting thing here is that this was meant to be read by a what? A human. Yeah, in fact, if we look at this, we'd have to count the columns here. How many wide is this? I bet that's 80 columns wide because that is the standard width of a printed page back in the olden days. Alt F11, I'm not even sure. Let's come in here and just see the length of that. Hello, are you home? Is anybody home? There we go. The length of that line, 79. Okay, so yeah, it's set up for an 80-column page. So it's 80 columns wide, 25 rows tall. That's what a printed page is. Even when you're talking about a typewriter. Would we still be having to work with files like this today? And if so, why? I'll answer the first question, yes. Now you answer the second question, why? Aha, this could be a government file. And that's the government systems that's working, and we're just not going to upgrade it. Folks, what do you think? Are there still really old systems? Tell me why those systems are in place. You're nodding. Why are those systems in place? They are, give me a characteristic. Well, they are what? Okay, well, they're archaic. That's what means they're old. Yeah, but why are they there? There's a reason. Okay, so they're doing the job. They're integrated and they're mission critical. It's a really expensive system to change, and it's currently working, doing everything that we need. Why would we change it? At some point, we might have to change it. These programs are typically, they're typically written in COBOL, Common Business-Oriented Language. Oh, it was the lowest grade I got in all my programming classes. I got a B- in my COBOL class. Oh, it's a hard language. We don't teach it anymore at BYU. But there's still millions and millions and millions, maybe billions of lines of code that are still running large companies written in this language. In fact, there's one school that I know of, University of Tulsa, that still teaches people to be COBOL programmers, undergraduate degree, and they're learning COBOL programming. And you might kind of chuckle and go, wow, what a dead-end job. These guys are starting at $130,000 a year, just as supply and demand. People aren't learning this. There's not many people learning this language anymore, and there's still kind of a big need for it to maintain these old systems. And so these systems typically were not ever designed to be interoperable. Why? There wasn't anything to interoperate with. We had one computer. What would we need to get the data off this computer to a different computer? There's only one computer. In fact, you think of the time back in the day and kind of where this, I'm not even showing the data anymore, where this data comes from, these kinds of reports. How would you, if you worked at a company that had one computer, how would you get the data to do your job? Do you know how you got your data? What would you say? I need data. And then what happens next? You have a thought, I need some data. And then what happens next? Yeah, someone has to print it. In fact, typically what happens is you get set up with a set of reports that you need to run your job, and either daily, weekly, or monthly, those printouts would get printed for you. They'd be delivered to you. There's a guy whose full-time job is just to deliver reports. He's got a cart with reports. He's going around the company dropping off the reports for the day to everyone who needs them. Probably not his full-time job, but maybe it's a part-time job. And so that was the world in the 1960s, 1970s, not so much in the 1980s. But a lot of these systems are still in place, and we've got to work with the data. So that's our goal today, is to say we've got a file that was meant to be read by a human. There's some structure to this data, and because there's some structure to it, we should be able to come up with a program to get the data out in such a way that we could then work with it and graph it. If you had to graph precipitation, over the year, what's that data got to look like? Well, first of all, I've only got a week's worth of data here. So there's going to be multiple files that I'm going to have to process through, and that's the idea. I haven't had you download a year's worth of data, but I've given you 3 files here to work with. And so, the idea is you'd have a whole bunch of these files, you would have to process them all, get the data into a format that you could graph, and then build the charts that you need to build in Excel. Are you ready to do it? Let's get down to business. All right. I'm going to close, File, New Blank Workbook. Close our good old founding quotes. All right, and I'll insert a module. Insert module. My Acme sub tester. All right, so that's going to be the one that actually runs this, and the one that we're going to process one file at a time, because ultimately what we need is some kind of loop, maybe some way to choose the folder, then some kind of loop to process all the files in that folder. We've done that in prior examples. We won't worry about that. But then we'll have another sub-procedure that's called process one. And we will accept a path as a string. All right. So here in our Acme sub tester, we will call process one, and I'm going to pass it this workbook dot path concatenated with, whoops, the path separator for my operating system, application.path separator, concatenated with, and then let's just go ahead and take the file, whatever file I have open right here. And then I'm just going to go ahead and save this workbook in the same folder with those other files. It's just kind of for convenience and you know, getting us going here. So we can get down to business. Save as, browse. I'm going to go find that same folder, which was in my downloads. And then it was weather data. I'm just going to put it in the same place. Gold Star database. I must have clicked on something I didn't mean to click on. Weather data. .xlsm. Debug.print the path. And then we should be able to run this debug.print. And that should at least print out the path of that file. Great. Users gov a. Downloads weather data. There's that file. Okay. So now we got to try to open that file. I believe as a text file, we could just say workbooks.open and give it that path, and it would open it in Excel. And it would just try to import that data into Excel as best as it could. And we could probably make it work that way, but that's not the direction that we're headed today. What we're going to see today is how to open the file just as a file. Not bring it into Excel at all. We're just going to open the file directory and then see what do we have to do to work with it. So are we ready to proceed? Anyone saying I'm not quite ready? Let me get caught up. Okay. So if I want to open a file, here's the way that I do it. Instead of printing that path, now that I know that works, I'm just going to say open. And then I'll give it that path. Now, I got to tell it what am I going to do with the file. Am I going to write to the file? In other words, if the file already exists, replace it with this new stuff that I'm writing? Am I going to append the file? In other words, if the file does exist, just put it on the end of the file. Am I going to read the file, which is what we'll do? Or am I going to just, open in the one file and let me read and write to it, depending on how I want to do it? Those are our basic four choices that we have with this approach to opening the file. So I'm going to say, I got to tell it what I'm opening it for. I'm opening it for input. Now, the input, this part right here is from the perspective of VBA, not from the perspective of the file. And I can imagine saying I'm going to open this file for input, and you might think, oh, this file is ready to take input into the file. No. It's from the perspective of VBA. I'm going to bring data into VBA from the file, so we're inputting from the file. Now here's the word part. I got to tell it a number as number 1. I'll put any number here I want as number 1. Today, in fact, there are kind of new ways to work with files we can create objects that are meant for working with files, but they're Microsoft objects. They only work on the Windows operating system. What I'm showing you here will work both for Windows and Mac if you end up needing to work in Mac. It's kind of the standard way to do it. Well, I guess it's now one of the standard ways to do it. We would have objects and we would have methods. Those objects would have methods and properties. There would be some kind of file system object that we would say, open a text file, call the open text file method from the file system object. This goes back to the 1970s, and so it's before BASIC had any notion of object orientation. And so the number 1 says, I need some way to keep track of which file I'm working with right now. What do you think? Could I have several files open? Maybe have 3 different files open for reading. I'm reading information from all these files and then writing out to a 4th file. Sure, I got to have some way to keep those files separate, and the way I keep them separate is by which number I assign to them. So open the path that got passed in here for input as number 1. That will open that file. Now, sometime before the end of this subprocedure, I'm going to close that file So I'll come in here and say close number 1. And now, in between, we've got to decide what to do, and there are several things that we could do. Now, because we've opened this for input, we've got to read the data out of the file. There's different ways we can do it. We can say, I just want to read a certain number of characters. Let's just see how to do that. I'll declare a variable here. Space these in just a bit. I'll declare a variable here called oneLine. We're going to use this one as a string. Doesn't make a whole lot of sense for what I'm about to do, but I could say this. I could say oneLine equals, and then there's a statement called input. I then input, I tell it how many characters I want to input. I want to input the first 1,000 characters from a particular file number 1. Maybe I say the number 1. I think I can put the number in there or not put the number in there. Then I'll close the file, and then we do a debug.print of oneLine. Online. That should be one line. And there I've printed off the first 1,000 characters of that file. That's maybe too many. Let's just take the first, say, 100. And there's the first 100 characters of the file. Seems like... Oh, yeah. Does it start with a 5? Really? 5 must have been left over. WSI Corporation monthly participation tabulation. Yeah, I think that 5 was left over. Clear that again and try it again. Well, I probably hit the 5 while I was typing. There we go. Okay, so that's one way. I could just say, I want to read a certain number of characters. I can go one character at a time if I want. You know what I could say? I want to read all of them. There's a function that tells me how long the file is. It's called length of file, LOF. And I give it a number, LOF1, and that will now read the whole file. It's going to read a certain number of characters because the input reads a certain number of characters. How many are we reading? However long it is. Alpha file number 1. And that should print off that whole file. And there it is. I only have 200 lines in my immediate window, but it's put it all up there. That's okay if you're working with small files. Because this has to put the whole file in memory. Can you imagine working with a file that's so big it's larger than the amount of memory you have? Yeah, easily. And so what we're going to see is how do we work with a really huge file? In that case, we got to say, you know what? I want to get a little bit of a time. So there's a different approach. So I'm going to leave this one line in here. I'll just comment it out. This reads a specified number of characters. Reads the specified S-P-E-C-I-F-I-E-D. Okay. But our approach is going to be, no. I just want to read in one line. So you'll notice that when we look at this file in a text editor, it's got, it's broken up into multiple lines. Now, is it really broken up to lines in the file? No. There's a character right here. It's probably a space. There's a space. That's character number 32. Another space, character number 32, 32, 32. Capital W, I don't know. That's character number 91 or something. I don't know. It's some number. And so it's all these. Well, what do we have way out here at the very end? Yeah, character 10 followed by character 13. No, it's character 13 followed by character 10. That's a special sequence that Windows knows to go, oh, that's the end of the line. And that's hardwired into this idea of working with files to say that is such a common separator for lines that we can say, you know what? We've got a statement that just reads one line in. And it just reads all the way up until we find that next end of line sequence. In fact, it's called not input, but it's called line input. Line input or input line? I think it's line input. I then tell it I always forget the order here. let's try number 1, comma, and then the variable I want to put it into, 1 line. Whew, it liked it. So that's pretty good. So line input number 1, 1 line. It's a little bit strange because it's not a function the way input is, where the function runs and then returns something. This is just a syntax we got to learn here in VBA. I tell it the file number, I tell it the variable name to put 1 line into, and that should now give me 1 line. That should just give me the first line. And there's the first line off that file. If I wanted to, I could read. Let's do this. I'll run this line twice. This is going to read the first line into the variable. What's this one going to do? Yeah, this is going to read the second line into the variable. What happens to the value that used to be there? Poof, it's written right over the top of it. So now if I run this, let me go ahead and clear this off. I should get the second line because I'm reading the 2 lines while the file is open, and then I'm just printing the one there after we've closed it. So it should be June to 10, November 08. I'll run this. There it is. I got the second line. And so now the nice thing about this is that we can now just say, you know what, I don't care how big this file is. I'm never putting the whole thing in memory. In fact, I'm never putting more than 1 line in memory at a time. Whew. So that's nice. This is a way that we can work with huge, huge files. In fact, you know, there are you know, you take a multi, you know, hundreds of gigabytes file, and there are very few text editors that can even open those files. Because most text editors make the assumption I can read the whole thing into memory. Notepad would do that. Notepad++ does that. I'm not sure about the new one that Microsoft has, VS Code, which is kind of a nice editor. It might be able to handle really huge files smartly, but most of them can't. So it's kind of a neat skill to have to work with something that's too big for files that you might not be able to look at any other way when the files are too big to look at. All right, so now our chore, so we now have the mechanics. We now have the ability to read 1 line at a time. Now we have to come up with an algorithm. How are we going to look through this file and figure out how to get the data that we need? First of all, let's talk about what data that we need. So if I'm going to be looking for daily precipitation numbers, so here's one of the things I'm going to need. Let's call this the station. Okay, so I'm going to need the station. So let's go ahead and make a variable for the station. What else am I going to need? I'm going to need to know the amount of the precipitation. We're going to get to this a little bit later, but what else do we need to know? Okay, someone said something first. I heard it. What was it? We're probably not going to need to worry about the totals because we're going to bring in the raw data. And once we have the raw data in here, we can calculate the totals any way we want to. Let's not bring in calculated data. Let's just bring in the raw data. I heard someone say something about the date. Now, the date is tricky because for this number right here, I need to know that it's the, someone help me with the Brazilian pronunciation. Is it just January? What? Say it again. Okay, let's deal with this one. How about this one? Patos, I can do that one. Okay, so for this number right here, for that 9, I got to know this is the Patos station. I got to know the 9. That looks so pretty good so far, but what's the other piece of information I need? That's part of what I need. The 5th of what? Of November, keep coming. Yeah, 2008. So the tough thing is that this other information is kind of spread out all over the place. The 5 is here. That's the only place that the day is shown. But now somewhere else I've got November of 08 is kind of the other part of that date. And so we're going to need, in fact, for this whole file, the month and year are constant. If we were to look at the other files, we would see that when you're at the very beginning of a month, if you have a month that's not a full week long, you get just the days from that month and year. So for a given file, the month and year is always constant. So let's start off with a variable that's just going to be the month and year. I'll call it moyear. Mo_yr. as a string. Okay, so in fact, okay, look here. I've read the second line. So right now I'm already reading the second line. And look at that. Mo year is there. Wonderful. The month and year is there. Now the question is, how am I going to find it? Any thoughts? Well, Professor Allen, you might just count in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Like starts after 18 characters. You don't like it. Why not? Yeah, what if it's January to something? What's going to happen here? Will they give us a 4-digit abbreviation for this year? Or is it going to push things over? We don't know. And if we had all the files, we'd go peeking around and we could answer that question. But we can probably write this in such a way that it doesn't matter. We can anticipate that that's going to change. If it changes, great. If it doesn't, we're still okay. Okay, so just counting over the number of characters is no good. What else? Okay, maybe spaces. If I'm going to split this apart by spaces, I've got spaces here to begin with, which is going to be a problem. Someone says split on the dash. If I split on the dash, I think I'm pretty good to say that whatever comes before here, before that first dash, throw it away. We don't care about it. What I need is what's in the second and third positions if I was to split in the dash. What about all these things that might be split afterwards? I don't care. As long as there's no other dashes that show up here, splitting on the dash might be pretty good. I like it. There's a question here? The question is, well, hey, down here you've got some other troubles, and that's like 4th of November, 08 to 10th of November. But what we're going to do is we know something about these files, and that is month and year is constant. So what we're going to do is we're going to read to the second line. And then we're going to pull off the month and the year, and we'll have the month and the year to work with for the rest of the time. So one approach I like is split based on the hyphens. That's not a bad approach. So another approach we could do is we could say, look, just find the first hyphen, and then take the next, 7 characters, 6 characters. We do that. I think either one's fine. Since the student suggested split, let's split. I think every time I've done this example before, we've taken the different approach, but let's go ahead and split. So let me go ahead and let me dim the date as variant. Okay, I've read in the first 2 lines, so now I have the second line in my variable. All right, so now let's go ahead and pull the year in. So the date equals split 1 line, and we're going to split it based on the hyphen. So now the date should be an array that has some stuff in it. It's a 0-based array, and so this should be what's in the 0 element, and then NOV should be in the next part, and then 08. So now I should be able to establish Moyer as the date sub 1 concatenated with a hyphen. And ultimately, I'm going to be bringing back my month and year together with a particular date. So I'm always going to be plugging a date into the spreadsheet that I'm building. So I'm going to just treat this as like a suffix for the day. So that looks pretty good. Plus, what's in the second position? And why don't I go ahead and put a hyphen on the beginning of it as well. So we'll just be ready to add on a day. So it should be, we don't know the day, but we know everything else. Because what comes next? Dash, month, dash, year. And that's what we've got, the dash, month, dash, year, then built in. It's delightful. Let's make sure that we've got that working so far. debug. What's that? Okay, wonderful. I guess I got a problem coming up that I haven't seen yet. That's okay. MOYR. And we'll run it. Oh, so we've got... Oh, bad news. And that is, if we're splitting by this, we've got... This is what's actually in that third position. So let's just do this. And for the date 2, instead of taking this, let's just split this right here. Let's split the date 2. Let's split it on a space, and let's take the 0th element. This looks a little bit weird to us, to see parentheses with a subscript coming right after this other parentheses. But remember that the split function returns an array. And so this part here will evaluate to an array, and now I'm just asking for the number 0 position in that array. In fact, it turns out the character that I delimit on is optional, and if I don't tell it what to delimit on, it will use a space. So let me just go ahead and run this again. And now I've got just the November 08, that looks pretty good. Let me just make sure there's nothing in those spaces after that. I don't think there is. I think that's just the carriage return that I'm seeing. So the trick is I could even get rid of this argument here, because if I don't tell split what to split on, it assumes a space. And so here I run it again, and it still has given me just what I'm after. Okay, great. So I got the month and year figured out. So far, so good. 1 down, 800,000 to go. Questions here? All right. So now our next task is, well, let's spend a little more time looking at the file. So what do we have here in this first block? This shows June of 08, July of 08, August of 08. What's going on here? Yeah, this looks like it's telling me what did we have in June? 0, and that was what percent of normal? 0% of normal. What did we have in September? We had 13, and that was 42% of normal. Down here we had 55 millimeters, and that was 149% of normal. So this is all month level data looking back. Right? This is a report that someone said, I need a report. What do you need on the report? I need 6 months precipitation back to know average, how we doing, and I need to know the daily numbers for the past week. So some chump wrote a program that generated this report to give that guy just what he needed. It's not what we need. We don't care about this first block at all. It's the second block that we're concerned with. This is the one that has the millimeters for the particular days. So we want to skip this whole first block. We got to get to this block. And if we look down, what we'll see is, where are we? This is this particular state. And then we'll come down. Now we've got, Sao Paulo. That's one I can almost pronounce. I probably pronounce it like a gringo, but here's Sao Paulo. And it's got, again, percent of normal for the past 6 months plus the data here. So this pattern's going to repeat. So I got to find something reading one line at a time that can help me figure out how can I know when I've scooted past this monthly data and have got to this precipitation in millimeters data. Any thoughts? Remember, I only see one line at a time, so I can't look. With a little work, I could say, well, we need to get 3 lines at a time in here. We could do that, but if we can, let's just deal with one line at a time. Give me something that says, hey, if you look for this, you'll be able to know where you are. Okay, so I heard 3 asterisks and total. Let's take total first, because that one I think I understand. Do I see total up here anywhere else? I don't see any total. So if I'm looking down here, if I've got something that says total, that looks pretty good. I don't see, let's just do a little search for it. Total? Yeah, total's only showing up in those blocks. Yeah, I like it. Now, I don't want to ignore 3 asterisks. That was a good, oh, so here we've got 3 asterisks here, but it looks like, yeah, I've got that same kind of a header up here in the monthly summary data as I do with here. So I could like search for 3 asterisks. I could search for 3 asterisks again. That would take me here. Then find the next line that's got 3 asterisks. That would take me here. So I could like say, do that twice. You know, go until I find it twice. But I like total better. In fact, I like norm better than total. Let me try that one. Yeah, you know what? If the right 4 characters are norm, that's the line I'm looking for. That's the line that's got the next block of data that I need. So total would work. Let's use norm just because it happens to be the rightmost character. It's a little bit easier to code. Not that much easier, but it's a little bit easier. So let's do that. So now, great, I've got my month and year. So now let me go ahead and give my little note. Find the days. Find the line with the days. Okay, so here's what I'm going to do. I'm going to put a little do loop in here. Do and loop. I don't know how many rows I got to read. It's different depending on how many stations there are in each one of the states. So, what am I going to put inside this do loop? How do I get to the next line of data in my file? I do a line input. And I'm going to loop until the rightmost 4 characters of something equals norm. The rightmost 4 characters of what? 1 line. I'm going to keep reading a line off the file, putting in the 1 line. I'm going to look at it. Is the right 4 characters norm? If so, get me out of here. If it's not, read the next line. Is it norm? Nope, read the next line. I'm going to keep reading the next line until I get to one that says norm. Okay. Let's see. If I just run this, that should let me out. That should close the file. That should print 1 line still. So that should print the month, year, and then we're printing the 1 line that we've gotten to by then. So I'm going to go ahead and run this. Oh, there they are. I have now the days that I need to go with my month and year. Whew. Question? Oh, would it be a good idea to plug do events in here? That is a really good idea. Do events. Yeah, because if you put norm in lowercase, you just put yourself into an endless loop. Ah, yeah. The question is, we're going to need to know something to get us out while we're searching for this next line of data. Yeah, we'll come back. Once we get to that point, we'll come back. Or do you want to put it in now? Question is this where it would go? I think this is where it would go, because here's where we're looking for the next block. All right, so let's do one more exit in here. And right after we read that line, let's do this. Let's say if, now, remember there was a statement called LOF that told us the length of the file. There's another one called EOF, that's just a Boolean variable. We had something like it when we're working with databases. It just tells us have I read past the end of the file. So if EOF, number 1, then stop. Let's just stop for right now. So this is telling us, wow, we were looking for the next group and we kept looking and we got to the end of the file. So we're going to have to figure out what to do when we get to the end of the file. But for right now, let's just anticipate that what we just did might run into the end of the file, and if so, let's just stop for right now. We'll have to figure some code later, but that will get us there. Okay, next trick is we've got to now pull in these days. Now, the hard part here is it's not always going to be 7. because if it's the last week in the month that has fewer than 7 days, it's going to have, might have 5, 4, might even have 1. It's possible that I've only got 1 column here in the middle. So we're not sure exactly what we're dealing with. So any thoughts on what to do here? Go ahead. Okay, so you might say, hey, just between, we could split this by call, and then we could split it by total, and then we could use that to figure out where we are. I'm okay with that. Let's go ahead and do that. I've already got a variable called the date that we used to split that we don't need anymore, so why don't we go ahead and use that one. Okay, so now we've got, let me put a little note here. Now we have the data header. Okay, so let me just go ahead and say, let's say first, what do we call it? The date equals split, and we're looking at one line, and we're splitting it based on, let's go ahead and split it based on call. Okay, and if we split that based on call, then our 0 will be what's before it, and then this will be our number 1 slot that has everything here. So let's just go ahead and immediately take the number 1 position. And we could nest this and split that again, but it gets really ugly. So let's do it with a separate line. So now let's split not one line, but what are we going to split now? The date. So we have now, by the time that first line runs, the date should be this. Right? Or actually, it should have the spaces too. It should be this. So now we'll split based on total, and we'll take the 0 position. Whew, I like it. Debug.print the date. Let's see what we got. Here's our the date. It's got spaces in the beginning and the ending, but it's got now all the dates that we're after. Now the trouble is I've got to cut this up into individual days, and I don't know how many they're going to be here. So any thoughts on that? Split seems like a pretty good choice, but what will we split on? What's that? Ah, no, okay, so split, I've got to give it a string to split on, so I can't give it a function. That'd be nice. Some languages let you pass a function in as an argument to another function, not VBA. So, So if I did space, here's what I would end up with. So here's my first space, and so I would get whatever's before that first space, which is 0-length string. And then here's my next space. I would get what's between these two spaces, which is a 0-length string. So I'm going to get a bunch of 0-length strings, and I'll have my numbers in there somewhere. So I could split it by the space, and then go through that long array and find out which ones are numeric, and pull those into some other array. That's not such a bad algorithm. There's a way easier way to do it. And it's not stuff I haven't taught you yet. It's just using the tools you've already got. So, first of all, why don't we just look at all these spaces and let's collapse sequential spaces down into a single space. Then we can split on it and it'll split perfectly. So, the trouble is, it'd be great if it was always 4 spaces between. Or is it 5? 1, 2, 3, 4. But is it always 4? No, because this 2-digit date eats up one of those spaces. So we could probably replace 3 spaces with 1 space, and then replace 4 sequential spaces with 1 space. But let's just make it a little bit more general. In fact, maybe we'll just write a function like this. That's interesting. Maximize. Let's make a function, function, called collapse shrink space. I'll pass it some data, and it will return a string. Do until, Oh, you know, this is kind of an interesting little side note here. Oh, data as a string. I'm trying to think if I've ever told you this before. You even mentioned this before. If I have a variable, and I pass that variable to a parameter. What is this, by the way? What is this? Someone say something intelligent about what I have highlighted. It's a parameter of a function, but what else is it? What am I declaring here? I'm declaring a variable. Yeah, allocate some memory for this. Now, there's actually a little shortcut the VBA does. It says, listen, if you're passing me a variable, in other words, if I was making a call to this, let me do it right here. Print the date. I somehow have to get a hold of this. Print shrink space. Is that what I called it? Okay. If I pass this something, it's got some spaces in it like this, then it says, listen, you've got a string literal here. It says, great, I've got to allocate some memory to receive this. But if I'm passing it something that's already a variable, I'm passing the variable down there, it goes, I don't got to create a variable to receive this. This is already sitting in memory as location. I'm just going to use this name as another name for whatever variable this is. Which means if I change this here, if I say data equals something else, it will not just change data, it will change whatever variable I passed into it as well. That can be really handy if you've got something big that you have to pass down because you don't have to copy it to another location in memory. It just uses that same location. And if you've got 3 or 4 things that you want your function to change, you can actually change them in the parameters that you send down. You can change them that way as well. But you can force it to always make another copy of the variable by saying this. The default, when you create a parameter, the default is to pass by value. That's the way it is. No, I'm sorry. It's by reference. Pass by reference means if you pass a variable down here, don't copy the variable, just use the same location in memory. But if I pass by value, which is by val, this will create a copy of the variable for me to work with. So if I change data here, it won't affect whatever I passed down. So let's a little note here, because it's the first time we've seen this. By val forces VBA to create a copy of a variable passed in. It's kind of a complex idea, and now that I think about it, I probably shouldn't have tried to introduce that to you today. Whoops. It's by reference, by ref. And that's the default. If I don't say by anything, it's by ref is what happens. Okay, but now I can say do until in string. That's looking for one string inside another string, starting at the first character, looking at data, and looking for 2 sequential spaces until that equals 0. Because 0 is what in string returns when it can't find it. And then all I'm going to do inside this loop is say that data equals replace, look at data, look for 2 spaces, replace it with 1 space. So replace is going to look through every occurrence of 2 spaces side by side and replace it with 1. Now it's already just considered those 2, and so it goes to the next one, it collapses that one, goes to the next one and collapses that one as long as it finds it. And so because I have this in a loop, it's going to continue doing that until it can't find any more occurrences of 2 spaces. So now I'm ready to return the results by trimming and passing back data. Trim will just take off the leading and trailing space, which I don't really want there anyway. So now I should be able to call shrink space. How convenient. I have this right here. And that gives me back a string with only one space between each character and nothing on the beginning or the ending. Questions? In the back? S-H-R-I-N-K, S-H-R. Oh, this one here? Oh, yeah, that was just an example, but you're right. S-H-R. I'm not sure we're going to leave that in there anyway. Okay, so now I should be able to say the date equals shrink space date. The only thing I'm not sure is I'm passing the date here, and I think this is probably a variant, not a string. So this may cause an error. If so, we'll fix it easily. So let me run this. Looks like it ran okay. I'm going to move my print of the date down below that line. And it looks like now I've got my date now as a string right down to that, something that I could really work with. So let's just do one more step to the date and say the date equals split the date. I can't say debug print the date now, but I can, because it's an array, but I can print one of the elements in the array. And that should give me the first, that should give me the first one. Yep, so there's the 4. Now just read the first position in the array, the number 0 position in the array, and that's that 4 right there. Great. So now I have an array that has the dates that I have to work with. Good. So I've got a string variable that has the month and the year. I've got an array that has each of my 7 dates, my 7 days. I'm feeling pretty good. As far as the date structure, I've got that built up pretty well. So let's take a look at what's next. So now I'm ready to get the data for each of the individual stations. All right, so how am I going to get to the right data? Any thoughts? So I'm on this, I've got this row right now. How am I going to get down to the right data? Might be able to look for a dollar sign, but what I'm not sure about is that some of these start with an asterisk, and it might have an asterisk here. And if I'm looking for an asterisk, I'm going to bump into this one. So if I look for, so that's possible. I could keep reading each time looking for a dollar sign or an asterisk. This one probably starts with a space, so that's probably okay. But I think it's probably a little bit more straightforward to say, you know what? I bet it's always the same structure. We've got the equal signs. Those are always going to be there. We'll have a blank line. We'll have the name of the state, a blank line, and then we've got the data. So now I should just be able to read forward a certain number. I think I'll be okay. How many do I have to read? 1, 2, 3, 4, 5, and then I'll have the right one ready to go. So let's just do a for loop for that. Do I have a control variable for a for loop? Not yet. So let me declare x. So I've got my date here. I don't think I need to print this anymore. So advance to the line data for x equals 1 to 4. Next. And then I'm just doing my line input. So now if I run this, because we're always printing off one line at the end of our loop, that should I'm kind of feeling like an endless loop here. Am I done? Oh. Save. I don't think I'm in an endless loop. Makes me wonder if I counted wrong. Do I need 5 to get there? Yeah, it looks like I need 5 to get to that line. Really? It was right here. I read 1, 2, 3, 4. Oh yeah, it is 5. Okay, so I'm reading 5, and now I've got this line set up. Okay. Now I'm wishing we read the dates a little bit differently, but we'll be okay. Okay, it does look like these states or these stations are always prefixed by either a $sign or an asterisk. I do not know what it means. It must have some meaning, but I don't care about it. I'm after just what starts after that. So I think in this case, I can probably just go ahead and take everything up to there. So what's that going to be? Just use the mid starting at the second character and taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then trimming it. I think we'll be okay. So get the station. Did we call it station? Station equals STATI1. Station equals the mid of one line, starting at the 2 and taking 12. And so let me go ahead and print the station here and see what I get. Yeah, looks like I got that station just fine. So far, so good. Oh yeah, let's trim it. Good idea. I'll just do that in one step. Trim. That'll trim the station down to get rid of those trailing spaces. Now, I've got to get the actual data. And if I had thought ahead a little bit, we could have used kind of the same approach for both pulling off the dates as pulling off the data, because structurally it's the same. We split by call and total because that was recommended by a student. It was a fine thing to do. But now we've got to find a different way to do this row because there's no call and total in there. So what should we do? Well, I think what I'm going to do is I'm going to pull. I know that we've got sometimes 3 digits, maybe 4 digits. So how far do I have to come in here to be safe? 1, 2, 3, 4. At least to there. Why don't we come right to here? Let's find out what that character is, what number that is. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So if I go 22 characters in, and then take 40 characters, I think we're going to get the data that we need. Okay, so let's create for ourselves another array. So we've got the date holding our days, and let's create one called the data. Ooh, those are really close to each other. It'll be holding those actual numbers. So we've declared another variable called the data, and we should be able to say the data equals mid of one line the mid of one line, comma. What did I say? Starting where? 22 characters in, and then taking 40 characters. Oops. That'd be okay as a string. It would convert it, but let's leave it as a number. Now, no reason to trim this one because we're about to send it down to shrink space. Should we do it right here on the same line? SHRINK space. So that will take whatever comes back from mid, shrink the spaces off of it, including the leading and trailing spaces. Oh, let's go for it, shall we? Let's split it too. And since space is the default, I don't have to tell it what to split on. And so now the data should be holding all those values. Whew, it's kind of a long line. It's the same thing that we did up here in 2 steps, we just did it in 1 step here. Where x equals 0 to the upper boundary of the data debug.print. You don't have to do this part. This is just me checking to make sure we got everything working okay. X and the data sub x. That should print out 0 through 6 and then this row of numbers 0000908. And oops. And there they are. So we now have that data in an array. I don't really need this around. I was just checking to make sure we had the array built right. Whew, I think at long last, we now have all the data that we need to write out the first line. Actually, it's going to be the first 7 lines in our data because we're going to put 1 row for each one here. So let's go ahead and do that. Hey, I had a for next loop already there. I'm going to leave that for next loop in place. That's what we're going to have to do. Let's actually create a function that will just append the data to the end of our list of data. So we haven't made the function yet, but let's just go ahead and call that. We'll call it writeLine. Write 1 line. And then I'm going to pass it what I want it to write, which is the station. I then also want the date, which I'm going to combine here. So called the date sub x concatenated with my month and year. That should be the date. And now I want the precipitation, which should just be the data sub x. And this is just a call to a sub, so I don't need any parentheses around it. Well, I got to write the procedure called write 1 line, but this is just going to say, hey, just here's the data, push it onto the worksheet. Let's go make the sub procedure for writing 1 line. Sub write 1 line. The trick is it's got to figure out where that line is, yeah? So, and I've got 3 pieces of data. Let me just call them A as a string, B as a string, C as a string. That looks really good. Oh, C as a string. Thank you. Let me figure out a row as a long integer. Row, and we're just going to assume the active sheet. Row equals cells rows.count. That's all the way down at the bottom, column number 1. And XL up dot row plus 1. So that's going to figure out from the bottom of the worksheet, come up until it bumps into text, ask for the row of that, and then add 1 onto it. That's the row we're going to have to write to. Cells row comma row, or row number row, column number 1, dot value equals whatever's passed in the first position, 2 and 3 will be B and C. A lot of work, but so far we should be printing out those first 7 days onto our worksheet. Should we give it a try? I think so. Biref mismatch. Okay. So here I am passing it. I told it to accept a string. And this is a variant. So I'm just going to convert it to a string. CSTR. And that'll be a string. And now I've written those first. Control zoom. I don't know how to zoom on this computer. So I've written that first data on here just like we need. Whew. What do you want to see? The lower procedure or right here? Up. All we have to do now is figure out how to make this happen over and over again. And we got 4 minutes to do it. So that should do the first line. And so, see, I've got the station. I've got to pull the data. So this block I've got to do for each line. So let's put this inside a do loop. Do and loop. Tab this in. And let's loop until, let's see. Then we need to read another line at the end of this loop. So we need a line input here. And then we will loop until one line equals a zero length string. Because I think we've got a blank line at the end of this. Yeah, so we're going to hit a blank line. We're going to continue to loop until we hit a blank line. That should now get that whole first block. Oops. If I spell until right. U-N-T-I-L. Try to hit F5. And so, I'm not picking up I'm not changing the station. I got to get the station in here. So this goes inside the do. Run that again. Now I've got that first block. And we're out of time. But what's next? I think all we need to do now is add one more loop that gets us the whole thing happening multiple times. And then we've got to find, let's see, where are we finding? Oh, no. We're doing a line input here until we find norm. Oh, I think that's it. I think we just got, let me just add it real quick. Do and loop. Save it. And I think because we already have that trap in there looking for an end of line, I think we're going to be okay. It'd be awesome if that does it. We found the end of the file. Do we have a pot load of data here now? Control down arrow. Yeah, like 1,000 rows. That looks great. So now we just got to figure out what to actually do when we hit the end of the file. What are we going to do? Well, we're going to want to close. We got like several loops to close here to get out of here, which is kind of ugly. So let's do this. Let's just close the file. close number 1, and then let's just end the program. A little work, we can jump all the way out of these loops, but we're out of time. So let me get rid of this close and this debug.print. And that's it. Let me clear this off. Run it, and that should run clean. We've got all the data. I hope we have all the data. Where's the data? There's all the data. Okay, folks, that's it. It's a really, really useful skill to be able to parse through an arbitrary semi-structured text file. You'll find that this is something that you might find occasion to do often. In fact, something you might do often in that internship working for Bamboo HR, because I know they're talking about importing data. So send me an email if you're interested in that, and I'll connect you up. Thanks for coming. Class dismissed.